Alright, welcome to the Algebra 2K Systems of Equations and Matrices review. For number 1, what is row echelon form for a 2 by 2 system? Give an example. Alright, so with row echelon form, you want to have that diagonal line of 1s. So I'm going to make my diagonal of 1s. Everything below should be a 0. And then the rest of these numbers could be just whatever they want them to be. Alright, then for number 2, what is row echelon form for a 3 by 3 system? Give an example. Same thing. You want a diagonal line of 1s. Everything below should be a 0. And then everything above could be any number. Alright, now for number 3, what is reduced row echelon form? So RREF for a 3 by 3 system. Alright, so reduced row echelon form is kind of the same thing. You have the diagonal of 1s. Below it you have the 0s. But also above you also have the 0s. And then for your constants, those could be whatever numbers. Alright, so the first row would tell you x equals some number, second row y equals some number, the last row z equals some number. Alright, then for number 4, write the solution to the systems of equations based on each reduced row echelon form matrix. Alright, so as you can see, we just have 1s and 0s, so this is reduced row echelon form. The first row is telling us that x equals 5, second row y equals 2, third row z equals 1. Same thing for number 5. X equals 4, y equals 2, z equals negative 3. Alright, for 7, 8, and 9, back substitute to calculate the solution for each row echelon form matrix. Check by using reduced row echelon form. Alright, so for number 7, it's in just row echelon form. We have the diagonal of 1s, everything below it's a 0. Alright, so let's convert this back to a system of equations. The first row is 1x plus 4y plus 6z equals 5. The second row is y plus 3z equals 2. The last row is z equals 1. Right, we know that z equals 1, so let's plug that in to the second equation. That's going to be y plus 3 times 1 equals 2. We know that 3 times 1 is just 3, so y plus 3 equals 2. Subtract the 3, we get y equals negative 1. Alright, so we have z is 1, y is negative 1. Now let's use those two to find x. So now we're going to plug y and z into this first equation. So x plus 4 times negative 1 plus 6 times 1 equals 5. Alright, so we get x minus 4 plus 6 equals 5. Negative 4 plus 6 is positive 2, so x plus 2 equals 5. Subtract the 2, we get that x equals 3. Alright, so our solution is 3, comma, negative 1, comma 1. Alright, so now let's do the same thing for number 8. So for number 8, we have a system of 1x plus 4y minus 7z equals 5. The second row is 1y minus 4/3 z equals 2, and z equals 3. Alright, so we're going to use back substitution again. I'm going to plug 3 into the second equation for z. So y minus 4/3 times 3 equals 2. So we have negative 4/3 times 3. That's going to give us y minus 4 equals 2. Alright, so we have y minus 4 equals 2. Now we're going to Alright, so my bad, this should have been a plus 4/3 z. This should have been a plus 4/3 times 3, which makes this y plus 4. Alright, so that's my bad. This should have been plus. Alright, so then minus 4 both sides, y equals negative 2. Alright, so right now we have y, we have z. Now let's plug those into the first equation to find x. Alright, so we have x plus 4 times negative 2 minus 7 times 3 equals 5. 4 times negative 2 is going to give us minus 8. Minus 7 and 3 gives us minus 21. Combine those, we get x minus 29 equals 5. Now add the 29 over. We get that x equals 34. Alright, so our solution is going to be 34, comma, negative 2, comma, 3. Alright, so now same thing for number 9. So on number 9 we have x plus 6y plus 5 over 6z equals 1/2. The second row gives us y plus 10z equals 3, and we know that z equals 6 from the third row. So again, let's use back substitution. Alright, so for the second equation, that becomes y plus 10 times 6 equals 3. 10 times 6 is 60. Subtract the 60. We get that y equals negative 57. Alright, so we got z, we got y. Now let's use both of those to find x. So now for the first equation, we have x plus 6 times negative 57 plus 5 over 6 times 6 equals 1/2. Alright, 6 times negative 57, that's going to be negative 342. 5 over 6 times 6 is going to give us plus 5 equals 1/2. Combine the negative 42 and the plus 5, we get x minus 337 equals 1/2. And then last thing we have to do is add the 337 to both sides. Alright, so we get x equals 675 over 2, or you could say 337.5. Alright, so the solution for number 9 is 675 over 2, comma, negative 57 equals 6. Alright, so now let's move on to number 10. In the space provided, write each system as an augmented matrix on separate papers, solve each using Gaussian elimination, list all row-by-row manipulations. Alright, so for number 10, we have a 2x2 system. I'm just going to go ahead and put this as an augmented matrix. Alright, so we have 5, 2, 11 for the first row, 1, 1, 4. Alright, so our goal is to put this in row echelon form. So since we need a 1 on this top left corner, and this is already a 1, the first thing I'm going to do is switch the rows. Alright, so we're going to switch row 1 and row 2. Alright, so now we have 1, 1, 4 for the first row, 5, 2, 11 for the second row. Alright, so we're good at the very beginning for step 1. We have a 1 on the top left. Now our goal is to make this 5 into a 0, this number 2 into a 1. Alright, so if I want to make this number 5 on the bottom left a 0, I'm going to have to multiply the first row by negative 5, add it to the second row. So the next operation is going to be negative 5 times row 1 plus row 2. Alright, so if I multiply negative 5 to the first row, we get negative 5, negative 5, negative 20. Alright, and then add it to the second row, which is currently 5, 2, 11. Alright, so the new second row is going to become 0, negative 3, negative 9. Alright, so the first row remained the same. Now the new second row becomes 0, negative 3, negative 9. Alright, so now we're down to the very last step, which is making this negative 3 into a 1. And if you want to make a number 1, just multiply it by its reciprocal. Alright, so the reciprocal of negative 3 is negative 1/3. So we're going to multiply that to the second row. Alright, so the first row remains the same. When I multiply negative 1/3 to the second row, we get 0, 1, and then negative 1/3 times negative 9 is positive 3. Alright, so we have the diagonal line of 1s. Below it we have 0, so this is row echelon form. Now we are going to convert this back to a system and then solve for x. So as of right now, we have x plus y equals 4, y equals 3. Alright, so we have x plus 3 equals 4, subtract the 3, x equals 1, so the solution is 1, 3. Alright, so that's number 10. Now let's move on to number 11. So by looking at number 11 right now, we see that the first row looks good. We have x, y, and z. Now on this one, we have the z on the other side. So let's move it back, or let's move it to the left side so they can all be in the correct form. So this should be, here's, I'll rewrite the first one, 3x plus 2y minus z equals 10. Now we need to add the 2z to the other side. So this system should have a middle row of x plus 4y plus 2z equals 3. Third row, 2x plus 3y minus 5z equals 23. Alright, so now for just space purposes, I'm going to solve this one on this piece of paper using Gaussian elimination. Alright, so the system again, it's 3x plus 2y minus z equals 10, x plus 4y plus 2z equals 3, 2x plus 3y minus 5z equals 23. So I'm going to convert this into an augmented matrix. Right, so as a matrix, this first row, come on, focus. Okay, there it goes. Alright, the first row is 3, 2, negative 1, 10. Second row is 1, positive 4, positive 2, positive 3. The last row is positive 2, positive 3, negative 5, 23. Alright, so we're trying to put this in row echelon form. Again, we want to make this 3 a 1. We already have a 1 right here in the second row, so let's just swap the rows and then step 1 is going to be done. Alright, so step 1, I'm going to switch row 1 and row 2. Alright, so the new first row becomes 1, 4, 2, 3. The new second row is 3, 2, negative 1, 10. The third row is 2, 3, negative 5, 23. Alright, so now I'm going to move this way for the next operation. Alright, so we have the 1 here. Now we have to make this number 3 into a 0. So I'm going to use this first row. Since we have a 1 here, let's multiply that first row by negative 3 and then add it to the second row to get a new second row. Alright, so let's multiply the first row by negative 3. That's going to give us negative 3, negative 12, negative 6, negative 9. Alright, the second row is 3, 2, negative 1, 10. Alright, so we're going to add that together, and that's going to give us the new second row. So 0, negative 10, negative 7, positive 1. Alright, so the new second row, again, it's 0, negative 10, negative 7, 1, and our first and last row stay the same. Alright, so again, this is the new second row. Alright, so we got steps 1, 2. Now next step, let's make that negative 10 into a 1. Alright, so I'm going to if you want to make something a 1, just multiply it by its reciprocal. So negative 10 has a reciprocal of negative 1 over 10. I'm going to multiply that to the second row. Alright, so our new second row becomes 0, 1, 7 over 10, negative 1 over 10. And then the first and last row stay the same. Alright, so we got steps 1, 2, and 3. Now we're just worried about the last row. We have to make this a 0, this a 0, this a 1. Alright, so if I want to make this number 2 into a 0, I'm going to multiply the first row by negative 2. So I want to multiply it by negative 2 so it cancels out with the positive 2. So negative 2 times row 1 plus row 3. So if I multiply the first row by negative 2, that's going to give us negative 2, negative 8, negative 4, negative 6. And then the third row right now is 2, 3, negative 5, 23. Right, so our new third row becomes 0, negative 5, negative 9, and positive 17. Alright, so the new third row, 0, negative 5, negative 9, 17. First two rows stay the same. Alright, so new row is row 3. Alright, so we got two more things we need to do. We have to make this negative 5 a 0. So I'm going to use the second row. The reason I'm using the second row is because since we have these two zeros here, they don't affect each other. 0 plus 0 is still going to be 0. If you multiply anything to 0, it's still going to be 0. Alright, so I'm going to take the second row, multiply it by positive 5, and then add it to the third row. Alright, so we can get 5 minus 5. Alright, so once I multiply the second row by 5, we get 0, 5, and then you can just plug this into your calculator. 5 times 7 over 10, that's going to reduce to 7 over 2, and then 5 times negative 1 over 10, that's negative a half, and then the third row right now is 0, negative 5, negative 9, 17. Alright, so Add these, 0 plus 0, 0, 5 minus 5, 0, 7 halves minus 9 is negative 11 over 2, negative a half plus 17 is 33 over 2. So this is going to be the new third row. Alright, so again, the new third row is 0, 0, negative 11 over 2, 33 over 2. And then last step, I want to make this negative 11 over 2 a 1, so I'm going to multiply by its reciprocal, which is negative 2 over 11 times row 3. Alright, so 1, 4, 2, 3 for the first row. Second row also stayed the same. So 0, 1, 7 over 10, negative 1 over 10. And now our new third row, 0 times that is still 0, 0. Negative 11 over half times negative 2 over 11 becomes a positive 1. And then we have negative 2 over 11 times 33 over 2. That's going to be negative 66 over 22, which is negative 3. Alright, so we're done with the matrix. We have it in row echelon form, REF. Now let's convert it back to a system and then solve for x and y. Alright, so this is going to be 1x plus 4y plus 2z equals 3. 1y plus 7 over 10z equals negative 1 over 10. And then z equals negative 3. Alright, so now let's plug z into the second equation. I'm going to do that off to the side right here. Y plus 7 over 10 times negative 3 equals negative 1 over 10. That's going to give us negative, so y minus 21 over 10 equals negative 1 over 10. Alright, so this is good because they both have the same denominator, so let's add the 21 over 10 to both sides. Right, negative 1 plus 21 is 20 over 10, and 20 over 10 reduces to the number 2. Alright, so we have z, we have y. Now let's use that with the first equation to find x. So x plus 4 times 2 plus 2 times negative 3 equals 3. Alright, 4 times 2, we know that's 8. 2 times negative 3, that's negative 6. 8 minus 6 is positive 2. Alright, so x plus 2 equals 3. Subtract the 2, we end up with x equals 1. Alright, so the solution is going to be 1, 2, negative 3. Alright, so for number 11, 1, 2, negative 3. Alright, so let's go to the next page. Alright, so for number 12, it says solving systems of equations using REF or RREF on the calculator. Alright, so number 12, we have the system of equations. Let's convert it to an augmented matrix. Alright, so augmented matrix is just the matrix you get after you convert it to a matrix from being a system. So from a system to a matrix, it's called an augmented matrix. Alright, so the first row is 2, negative 3, 4, 19, 5, 4, negative 2, negative 25 for the second row. And then the third row, we have 1x minus 6y. Since we don't have a z, just put a 0 in place of it, and then it equals negative 9. Alright, so let's put this matrix in reduced row echelon form. So let's go to the calculator. See if the focus is, alright, there it goes. Alright, so y'all see right here where it says matrix in blue? We're going to go to that. So second matrix. You're going to see three options. We're going to go to edit. We're going to edit matrix A first. So we want 3 rows and 4 columns. So we're going to make it 3 by 4. The first row has 2, -3, 4, 19, 5, 4, -2, -25. Third row, 1, -6, 0, -9. Alright, so just always double check your matrix. Just make sure you have the correct numbers in there. Alright, so I think here I'm good. So then I'm going to go back to the blank screen. So second quit or second mode. Now go back to second matrix. We're going to go to math. Scroll down to where it says RREF, so the one with 2 R's. Alright, so 2 R's, hit enter. You should have RREF with an open parentheses. Now go back to second matrix. Now we're in names and we're going to input matrix A. And then just hit enter, and then you get the matrix in reduced row echelon form. So this form gives you the solutions right away. Alright, so the matrix that we have is 1, 0, 0, -3, 0, 1, 0, 1, 0, 0, 1, 7. Alright, so this first row is telling us that x equals -3. Second row, y equals 1. From the third row, z equals 7. Alright, so this will give you the solution right away, RREF. Alright, so let's just kind of go over that again. So you're going to go to second matrix, start off on edit, put the numbers in the matrix, go to second quit, back to second matrix, go to math. So again, we started at edit, went back to the blank screen, now you go to math, go to RREF, hit enter, then back to second matrix. Now we're in names and we're going to input matrix A. So enter, enter. Alright, so let's move on to number 13. Alright, so for number 13 it says roast beef has 25 grams of protein, 11 grams of calcium per servings. A serving of mashed potatoes has 2 grams of protein and 25 grams of calcium. How many servings of each are needed to supply exactly 25 grams of protein and 61 grams of calcium? Alright, so let's look at this again. We have roast beef. It contains 25 grams of protein, 11 grams of calcium per serving. A serving of mashed potatoes has 2 grams of protein, 25 grams of calcium. And we're trying to find how much servings of each roast beef and mashed potatoes we need to get 29 grams of protein, 61 grams of calcium. Alright, so first I'm going to identify the variables. So we have, I'm going to make roast beef R. So R is servings, or number of servings. Alright, so number of servings of roast beef. And then mashed potatoes, I'll make that M. M is number of servings of mashed potatoes. Alright, so I'm going to make a system of equations out of this. Alright, so one of the equations should describe one of these things. Alright, so let's start off, since we're trying to find how much, or we want to get to 29 grams of protein, 61 grams of calcium. So we're trying to find how many servings of each of these. So R and M are acting like our X and Y. So let's make the first equation for protein. Alright, so for protein, we have 25 grams of protein per serving of roast beef, so 25R, plus 2 grams of protein for each serving of mashed potatoes, so 2M, and the needed supply of protein has to be 29, exactly 29. So 25R plus 2M equals 29, so that's for protein. Now let's make one for calcium. So for calcium, we need 61 grams total. So roast beef has 11 grams, so 11 grams of calcium per serving of roast beef, plus 25 grams of calcium per serving of mashed potatoes. So 25M, and we need exactly 61 grams. Alright, so let's convert this system into a matrix. Alright, so the first row is 25, 2, 29. Second row 11, 25, 61. Alright, so the first column represents R, second column represents M. Alright, the first row represents our protein, and then the second row represents the calcium. Alright, so let's use our REF again using the calculator. So we're going to go second matrix, edit. Alright, this time we have 2 rows and 3 columns. So we're going to make this a 2 by 3. First row contains 25, 2, 29. Second row contains 11, 25, 61. Alright, so then go back to the blank screen. Second matrix, now we're in math. Scroll down to RREF. Second matrix, input matrix A, and then enter, and then we have our matrix. Alright, so using the calculator, I got 101012. So this is RREF. Alright, so what this matrix is telling us is if we want to get exactly 29 grams of protein and 61 grams of calcium, we need 1 serving of roast beef, alright, so remember this is R, this is M, and then we need 2 servings of mashed potatoes. Alright, so 1 serving of roast beef, 2 servings of mashed potatoes. Alright, so next one, number 14. Alright, so number 14, it says a stadium has 49,000 seats. Seats sell for $25 in section A, $20 in section B, and $15 in section C. The number of seats in section A equals the total number of seats in section B and C. Suppose the stadium takes $1,052,000 for each sold out event. How many seats does each section hold? So we're trying to find how many seats are in each section. Alright, so let's define the variables. Let's make a number of seats in section A. And then just do the same thing for B and C. So B, number of seats in section B, and then C, number of seats in section C. Okay, so be very specific when you define your variables. Right? You don't want to just put section A, because what are you talking about section A? Are you talking about the price, the total number of seats? So be very specific when you are when you label the variables. So then let's make a system of equations out of this. So the stadium has 49,000 seats total. So that means A plus B plus C, those number of seats have to equal 49,000. So A plus B plus C equals 49,000. Right, and then so that's from this. And now let's make the second equation. So we know section A seats are 25, section B are 20, section C are $15. All right, so 25 for section A, so 25A plus 20B plus 15C has a total amount. So if you sell out all these seats, the profit should be $1,052,000. All right, so from this sentence and from this one, we got this. All right, so now for the next equation, we have the total number of seats in section A equals the total number of seats in section B and C. All right, so the number of seats in section A equals the same total number of seats in section B and C. All right, so this is the system, but if we want to put it in a matrix, wait, hold on. So this came from that. All right, so if I want to put this into a system, these variables have to be on the other side. So we're going to have to subtract the B and subtract the C. All right, so A minus B minus C equals 0. All right, so let's make a matrix out of these three equations. So we have this one, and now we just made this one because all variables have to be on one side. All right, so from the first row, we have 1, 1, 1. And then let me make some room to write down 49,000. All right, so then for the second row, we have 25, 20, 15, and 1,052,000. And then for the third row, we have 1, negative 1, negative 1, 0. All right, so this is why we have to move B and C to the other side, because each row or each column has to be for one variable. So we have A, B, and C. All right, so we have this matrix set up. Now let's use the calculator again to get the solution. So second matrix, go to edit. This time we have 3 rows, 4 columns, so 3 by 4. First row contains 1, 1, 1, 49,000. Second row, 25, 20, 15, 1,052,000. 52,000. Third row, 1, -1, -1, 0. I go back to the blank screen. Second matrix again, go to Math. Go to RREF. Go back to second matrix, input matrix A, and then you get the solution. Alright, so in reduced row echelon form, we get 1, 0, 0, 24,500. Second row, 0, 1, 0, 14,400. And then last row, 0, 0, 1, 10,100. Alright, so what this is telling us is section A. Here, let me write this. Alright, so we have 24,500 seats in section A. We have 14,400 seats in section B, 10,100 seats in section C. Alright, so that's number 14. So we got to set up the augmented matrix first. We plugged this matrix into the calculator, got back the reduced row echelon form. So RREF, form of the matrix, which gave us the solutions. A equals 24,500, B equaled 14,400, C equaled 10,100. So that's how many seats are in each section. Alright, so now for the last page. Alright, so for the last page. Alright, so number 15. A changed machine contains nickels, dimes, and quarters. There are 75 coins in the machine. And the value of each coin, or the value of the coins, is $7.25. There are 5 times as many nickels as dimes. Find the number of coins in each type of machine. Alright, so let's set up the variables first, or define them. Alright, so N is going to be number of nickels. Alright, D is going to be number of dimes. Q, number of quarters. Alright, so from the second sentence, there are 75 coins in the machine. Alright, so together, the number of nickels, number of dimes, and number of quarters is going to be 75 together. So N plus D plus Q equals 75. Right, we should know how much each of those coins is worth. So since together they have a value of $7.25, we're going to put a value for each one. So 0.05 N, because 5 cents per nickel, plus 0.10 for dimes, plus 0.25 for quarters, equals a total of 7.25. Alright, so now for the last sentence, there are 5 times as many nickels as dimes. So that's telling us nickels, so the amount of nickels is 5 times as many nickels as dimes. So N equals 5 times dimes. Alright, so the amount of dimes times 5 is the same amount as the nickels. Alright, so then we have the N on this side, the D on this side. Let's move all the variables to one side. So I'm going to subtract the 5D. We get N minus 5D equals 0. And now let's convert this into a matrix. So augmented matrix, the first row is 1, 1, 1, 75. Second row is 0.05, 0.10, 0.25, 7.25. And then for the last row, we have 1 for nickels, -5 for dimes, 0 for quarters, and then 0 there. Alright, so let's put this again in the calculator. Alright, so second matrix, edit, make sure it's a 3x4. So 1, 1, 1, 75, 0.05, 0.10, 0.25, 7.25, that's the second row. Now the third row, 1, -5, 0, 0. And then looks good. So second mode, back to second matrix, go to math, go to RREF, go back to second matrix, now insert matrix A. Alright, so this matrix in row echelon form is 1, 0, 0, 50, 0, 1, 0, 10, 0, 0, 1, 15. Alright, so we can interpret this as there are 50 nickels, there are 10 dimes, and 15 quarters. Alright, so in the machine, there are 50 nickels, 10 dimes, 15 quarters, just from looking at this matrix. Alright, so this is the solution matrix, reduced row echelon form. Alright, so now we're down to the last two. Number 16, solve using substitution or elimination. So for number 16, it says solve using substitution and elimination. Trying to see if this focuses a little bit better. Alright, so for this one I'm going to start off with these bottom two equations. Alright, we have y and z. We could just get rid of one of those variables using elimination, and then we could find either z or y. So for this one, I'm going to eliminate the y value. So if I want to eliminate the y value, I have to multiply the second row by 10. When I do that, we get 10y minus 10z equals -50 for the second row. Alright, so I just multiplied this one by 10 and just rewrote it underneath this one since we're going to do the elimination. So -10y plus 10y cancels, or just goes to 0. -7 minus 10z, so minus 7z minus 10z is -17z, and then 16 minus 50 equals -34. Alright, so then divide -17. We get z equals +2. Now that we have z, let's plug it into one of these original ones. I'm going to plug it into the second one since it's easier. We know that z equals 2, so if I plug in 2 for z, we get y minus 2 equals -5. And so again, I plugged in 2 into the second equation, and then add 2 to both sides, y equals -3. Alright, so now since we know y and z, let's plug it into the first one to find x. So x minus 2 times -3 minus 2 times 2 equals 6. Right, from that we get x plus 6 minus 4 equals 6. 6 minus 4 is positive 2. Subtract the 2, x equals 4. So the solution for number 16 is 4, comma 2, comma negative 3. Alright, so now let's do number 17. Alright, so for number 17, let's use the bottom one. All we have to do is divide the 3, and then that's going to give us z. So z equals 1. Alright, so we know z is 1. Let's plug it into the second equation to find y. Y minus 1 equals negative 2. Add the 1. Y equals negative 1. Alright, so we got z, we got negative 1. Now let's find x using the first one. Alright, so x minus 2 times negative 1 plus 3 times 1 equals 7. Negative 2 times negative 1, a negative and a negative make a positive 2, plus 3 equals 7. 2 plus 3 is 5. So we got x plus 5 equals 7, subtract the 5, x equals 2. Alright, so our solution is going to be 2, comma negative 1, comma 1. Alright, and that's going to be the end of the review.